Enjoy the session.
Hello, everyone. Welcome to this afternoon session. Thank you for joining basically now. Also to the people who are watching us. So remember, you can always make questions through the chat that I will later on read. So this session, we have prepared 3 talks. They are kind of different, they are transversal, but still they are really, really important. So the first one, we will welcome a colleague from the BSc. So on the Spanish network of supercomputing, probably I have changed the name. Just give me a second. The second one, we will have an NGO. And finally, talking about model, how we can contribute to, with our time to this initiative. And finally, we will close the session with the Bioinfo for Women program, where we will introduce the program itself and different activities they have had. So without any further delay, please. So Alberto Gomez comes from the BSc, as I said. He will be speaking about the Spanish Supercomputing Network, RES, in Spanish. And it's not just about HPC, but it's also about data and the HPC and data resources for a scientific revolution. Please.
Okay. Is it on? Yeah. Hi everyone. I hope you enjoy your lunch. So as Michael said, I am going to speak about the Spanish Supercomputing Network. We are an institutional sponsor of this conference, so we kind of bought our way into the conference, but that's okay. I see here. Cool. Perfect. So Spanish Supercomputing Network, what it is? Well, it is a network of 14 institutions throughout the whole of Spain. You can see in the map. We are 14 institutions, but we are 16 supercomputers and 9 data management center. So together, what we have is a combined capacity of 22 petaflops, which means 22 million billion, maybe 10, 15 operations per second, and then a 20 petabyte storage capacity. We offer up to 800 million CPU hours per year through our competitive calls, and we have around, we said 1,000, I don't know if that's really accurate, but yeah, we have lots of users throughout the year, and we are mentioning plus 200 scientific papers. We should be mentioning more, but some researchers forget to mention us, even if they use our resources, but there's no resentment there. But please, if you use it, mention us. As I said, we offer our resources through competitive calls. We have 4 throughout the year, 3 for computing resources and 1 for data access. And well, we are also, as I said, a Spanish unique scientific and technical infrastructure network. So a long name just to say that we are also a member of a network of institutions that are for technological and research development. So the 14 institutions that are composing the supercomputing network are the ones on the bottom part of the slide. As you can see, there's Catalonia, there's Madrid, there's Valencia, Navarra, so on. So, as I said, the access is through competitive calls. We have 3 competitive calls for computing resources. And why do we do it? It's because we want to maintain the quality of research that we have at the moment, and we also don't have the capacity to fulfill all the requests that we have throughout the year. We have around 150, 200 per call, so we don't have that capacity to fulfill them all. If you're granted access to the supercomputing, you have 4 months to use the HPC resources. And normally, most of our users are researchers as you, but we are also open to SMEs when they are doing like R&D projects, or we can also grant preserved hours for people who have asked for EU projects, and also for novel users who haven't used HPC before. So it is important to know that we divide our resources in three specific areas, as you can see in the screen. We have astronomy and space and science. We have physics, mathematics, chemistry, solids, homogeneous chemistry. I think the last one was life and health science. That it will be like the most important for you, I guess, for this conference. So this is for computing resources. As I said, 3 per year, each 4 months. But since 2020, we also offer access to data services. Why? Because there are scientific groups who have need to store like large sets of data, and they need to mix it. They need to combine it with computing or data resources that we offer. So we started in 2020, as I said. There's only 1 per year because we are starting with this service, and we only have until date like 20 petabytes capacity. We started with 9.3 petabytes. We are now at 20. We hope to be at 34.8, I guess, at 2024. So we are increasing. We received what we selected. We received more, but we selected 8 projects of data in 2020, and then we selected 12 in 2021. Next call is in November. So we hope to increase the number of projects that we select. So yes, if you're interested, apply. For both computing and data calls, there are a specialized support service that we provide at the Spanish Supercomputing Network in case you do have any doubts before applying or when using the resources. So maybe I'm speaking too fast, but I guess that you understand what I'm saying. Well, besides offering computing resources on the one hand, and then data access on the other hand, we also offer RES events, what we call. Those are events that we organize, well, not really organize, some of them. For example, we have the scientific seminars like this one. You can see is the first logo that we put. And we didn't really organize anything of this. We only were invited to talk. But what we do is that we support financially the organization of these events. Why? For 2 reasons mainly. One, because we want to promote what we can do at the Spanish Supercomputing Network. We want to promote what we offer so we can increase the number of researchers and other users or potential users that use our services, and we can upscale, we can improve the quality of the research that is using those services. And 2, because it is our goal as well just to support the scientific community, and we believe that these kind of events really help put people together and share knowledge. We sponsored 4 events this year. I think we have computational chemistry that it was at the beginning of September. Computer architecture was at the beginning of September. This one, those 3 were in Barcelona, and then we have another about computational biology in Madrid. Normally, we offer this call at the end of the year or the beginning of 2023, I guess. And we still haven't launched it, but if you are thinking of organizing a scientific seminar, you can access, and then we'll see if we grant it. And we also offer like technical training workshops. Last that we did was last week at the annual conference. It was about various topics. One was hybrid supercomputing. Was also about programming models for GPUs, etc. They are varied. We don't have a specific timeline for those training workshops, but we do it periodically. And our biggest event is the annual conference. Last edition was last week, so we are still a little bit hangover from that. It was 3 whole days. It was in Cáceres. We tend to change the city every year. And what we do there is that we select the MVPs, I guess, the best player of the past year from the people that have used our resources, and we celebrate what they have achieved using the Spanish Supercomputing Network resources, I guess. It's great fun. Last week it was in Cáceres, so it's a little bit farther from here. But next year we'll be in Barcelona, so you're welcome to register. It's normally for free, so. I've spoken to what we offer, and now we are going to run a simple application in case that you have doubts on how to do it. We have our access protocol on the website. I know that the website is probably not very user-friendly, but we are trying to change that. But this is the current website that we had, so first step that you need to do is to, if you don't have an account already, you have to create one. I know it's simple, but some people try to access without creating an account. Before applying, you just need to realize, you need to bear in mind that the access that we offer is only for 4 months, so you may have a long-term project. Beware that there's what you can access, it has to be maybe like one experiment or one part of the project that you can really, in which you can really achieve significant difference in those 4 months. There's always the option of continuity. You can apply again and it can, for the same activity, but you are not, you may not be we may not grant you success again, so you have to reapply. We added a priority requirement at 2020 for those activities and projects related to COVID-19. You can imagine why. We have decided to maintain that priority in case that, because we saw that it didn't affect the number of applications that we received. I think right now COVID-19 applications for the last call that ended last week was around 2% of the applications. So we decided to maintain the priority just in case. And now, first what you need to do is to give a title. I guess that won't be hard for you. The title isn't really important for us. What is important is that you apply to the specific area in which you want to set your activity. We have the 6 that I told you about, the astronomy, biology, etc. It is important to pick the right area because we have the access community who does the formal revision, and then we send those applications to independent experts of those 6 areas. So if you have a project about biology and then you put it under astronomy, that will be sent to the astronomy aspect, and they probably won't understand what you're saying, and you probably won't be granted access. So it's your loss. And also, you can decide the type of application. The standard, that is the one in which you are given like 4-month access. The one to pre-reserve hours for EU projects, but those projects have to be later granted and approved by the EU. If they are not approved, you won't be granted those hours. And then there are this option for the people who haven't used HPC resources in the past. So there's a section of the application which won't apply to you, which will be the history that your group has in HPC, of course. But this option is only for the people who haven't used HPC resources more than a year. And then, I don't know if you can see the screen, but it says on the A section that you have to give a brief description of the project. So that shouldn't be hard. You know what you're working on. Then what you need to do, in case that your project is inside another technology recognized project, you need to give another brief description. And it is important also to include the grants and funding that you have received for those projects. Those can be for European projects, national or regional. It is important to indicate that, because that will give you an advantage in the application. Then what you need to do is check the software components that you really use. 1 minute? Okay. That you really use, and then you need to put the personal data, so for the people who are leading the project. For the project leader and the other people who work with you. Then an abstract for publications, because we publish the list of the activities that are granted access for one call, and the CURES, which means the REST Users Committee, which is an independent body, which will raise concerns, the concerns you have to REST coordinators, just to hear what your experience is. This is a summary of what we do. We offer access to the supercomputing in Spain. We offer access to Europe. We offer support for European calls. We sponsor scientific seminars. We have the annual users conference, etc. Contact us if you have any doubts, because I figured that I didn't have enough time to explain this clearly. And follow us for more info updates. And that's it.
Thank you very much. No, don't run away. There's still time for questions.
Is there questions?
Any questions?
Are there? Yes.
Please.
Well, thank you for the talk. I have two questions. So first of all, in your infrastructure, do you have possibility to compute on patient data? And the second question would be, in establishing that infrastructure, have you compared to commercial providers? Are they somehow competitive in their offerings or not?
I'll start with the second question because I didn't hear the first one really clear. So the second question, we don't really compare to commercial users. We don't offer commercial access because we are publicly funded. But I guess that our value would be that we offer support to the users in the use of the HPC resources whenever they need to, I guess.
Okay. The first question was about whether you use the Mare Nostrum, for instance, facilities for analyzing patient data.
I'm not really sure. To be honest. And I don't want to say anything false. So let me get you back on that, to be honest, because I don't know. Probably we do.
Somehow we do. So,
yeah.
For instance, 40% of the ICGC data was analyzed at the BSc years back.
Through the data access, through the data services, or yeah.
Yeah, it was a singular project.
We do it.
So thank you. Just for me to understand, so that I got the point. So there is a call, and we can apply to this call, and what you explain is the process, how to apply?
Yes.
So, okay, so this is going to be open in November, so we can apply by then, I guess.
Are you referring to computing or data? It depends.
Computing.
Computing, okay. So,
well, both.
No, it's the same process, but there's one for data and 3 for computing. So what we do is that you can apply whenever, except the 6 weeks after we close a call, because we need to analyze all the applications that we have, and then we need to pass from the access committee to the scientific community and then the technical committee itself. We take about 6 weeks, and then we open the call again. Once we open the call again, you have until the, I think next call will close around 4 months, mid-January. Yeah, mid-January, I guess. We will open in end of October, and then you have all those months just to apply. Around 3 months, I guess.
And how many requests do you get, and how many of them do you finance, or you?
It depends. It depends on the computing hours that they ask. Mm-hmm. We have several limitations. If they ask for more than 10 million hours, we ask them to justify what they want that amount. We had around 200 applications per call, I guess. Yeah, around 200. And then we try to finance as many as we can. It depends. And it also depends on the area, because we have, for the last call, this is not confidential data, so I can say it. For the last call that closed last week, we have for physics around 50, and then for chemistry, solids, it was 16, 20 something.
Okay.
So yeah, we give as different priority. For those who are within the really strategy, they have priority A, and then for those who are less priority, we have priority B. And it also depends, we try to distribute the amount, not for each application, but we try to get all supercomputers in all of Spain at full capacity for the rest. So most people ask for Mare Nostrum, but you are not guaranteed that you will have access to Mare Nostrum. I know it's the fastest one, it's the biggest one, it's the most known one, but there are the others that also work.
Okay, thanks for so many details.
Sorry, we are a little bit late.
Just one last question. How are data transferred to your premises?
Through the data management team.
Okay.
Yeah, we have a data management team that offers support to the data services, and they save way.
Okay, thank you.
In case you have any questions, I will be at the booth at the beginning. So.
Okay, wait, my final question. So,
you have one?
Yeah, I have one. So you had been talking about Spanish resources, the rest. What about the European resources for our colleagues that are not from Spain?
I was planning to mention that on one of the last slides, but then I have to rush through that. So we normally used to give support to those researchers who were interested in PRAISE. You probably know what PRAISE is, I guess, or no? Well, it's like the Spanish Supercomputing Network, but in Europe. Now the PRAISE is limiting its resources, we can say that. There's the Euro EHPC joint undertaking that finance several projects, including the EuroCC, which is the National Competence Centers, but that's for SMEs primarily. We offer support for people who want to apply to those goals. So we changed a little bit from PRAISE to Euro EHPC. PRAISE still offer computing resources, and we suggest that you try to apply to them because they normally don't get filled out to the end.
Okay, now it's time for the next talk. Thank you very much. So our next speaker is Miquel Duran. Miquel Duran will talk about Ercilia. Ercilia is an NGO. He will explain better than I do. And the talk is about Ercilia as a hub of open source AI ML model for drug discovery and global health. So, Miquel, welcome.
Thank you. Can you hear me well? Yeah? All right, so first of all, thanks to the organizers for being so kind and giving me the opportunity to present in front of this audience. I'm not used to presenting in front of computational people, so it's a pleasure today. I will present Ercilia, which is a small nonprofit, pandemic-born, we can say. It's only 2 years old, and it's based in the UK. We are a charity. So the goal of Ercilia is basically the goal of every global health institution. Our mission is to strengthen the research capacity against infectious disease and neglected diseases in low and middle-income countries with the ultimate vision of achieving a more egalitarian world. I guess we are all acquainted with this view of the world according to land area. If we are coloring the world, as I'm doing here, by income, you can see that most of the income in yellow and orange is focused mostly in the global north, the so-called global north, whereas there is a purple region mostly focused on Africa that is of lower income, as we know. When we plot the world according to actually the disease burden previous to COVID, we can see very clearly that in Africa especially, that is the region of the world with less income, there is an abundance, an overwhelming abundance, I would say, of infectious disease burden. And if we contrast this view of the world with the view of the world that basically plots countries based on the scientific outcome, number of publications, you can see that the region of the world that is Africa basically shrinks, which means that there is a clear unmatch between the research capacity and the diseases that are affecting this region. This translates, at least previous to the pandemic, in the fact that, as I said, only less than 5% of the world research output comes from low-income countries. 6 of the top 10 causes of death in low-income countries are still infectious diseases, but only 10% of the drugs that are currently under development are targeting these disease areas. So there's clearly an imbalance here, and this is precisely what we are trying to tackle with our small nonprofit. Of course, this is a formidable task. This is not something we can do as a standalone initiative, but we identified 3 principles that we believe can be interesting and contribute towards this mission. The first one is to work in the free and open source domain. Everything we do is we share it in real time under, of course, the most permissive licenses, no patents, and we try to encourage reproducibility of everything we do. We favor, and I would say that this is the most important pillar of what we do, we favor in-country research. We try to avoid this notion of helicopter research where scientists from the global north just travel there, gather data, come back, analyze and publish results from the global north. We try to the extent that we can, revert the situation, and we actually spend most of the time actually in sub-Saharan Africa doing research there, and we implement our tools in situ. And finally, the third pillar, I think that it's also very important. We try to be sustainable. We don't believe in just action, doing an implementation and then going away. We try to ensure that everything we do remains there, and therefore we have to build some capacity, identify some champions there, and train them on the kind of things that we do. So the things that we do, there could be many, but we chose basically 2 fields, and we work at the intersection of these 2 fields. The first one is artificial intelligence and machine learning. Why? Well, because it's very cost effective, as we know. Implementation is relatively fast. We can do this remotely. Remember, we were born in the pandemic, and it's relatively domain agnostic, so we can hopefully contribute to different research topics. However, we focused most of our efforts on drug discovery. Why? Because we have a relatively good track record on drug discovery already. Drug discovery, as we know, especially small molecule drug discovery, is still very important for neglected diseases because medications are cheap, small molecule medications are cheap, and there are a few inspiring initiatives like the Medicines for Malaria Initiative, Drugs for Neglected Disease Initiative, Open Source Malaria, etc., that have been quite inspiring for us. The idea or the promise of machine learning and artificial intelligence applied to drug discovery is basically summarized in this graph. The promise is that we will be able to discover drugs in less time compared to traditional drug discovery by having the capacity of screening more candidates. Okay? So as we all know, and we've heard a lot about it already in this conference about how machine learning and artificial intelligence works, the machine learning cycle is quite complex, and it almost always starts with data. So data is at the center of the machine learning cycle, and then we need to process the data, we need to train machine learning models, we need to fine-tune them, we need to validate them, first internally, then externally, and then finally we need to publish. So most of the research stops at this second last layer, which is the external validation, where we basically manage to publish a machine learning model out there in the literature, and the machine learning model most of the time just stays there. So the focus of our initiative is actually to add a last layer to this machine learning cycle, which we call the deployment level, which basically takes care of gathering all of this machine learning knowledge for drug discovery, bundling it in a way that is actually usable for researchers that have no experience, and then helping them actually using it. The idea at the end of the day is that a researcher without expertise in data science, working typically in the global south, will be able to input a query, typically a drug, and get an output, for instance, the predicted targets of this drug. Okay? So what do we do in practice? In practice, basically our work is kind of philanthropic. We just read the literature, and we identify machine learning and data science research that we believe is interesting for our topic. Sometimes we are lucky and we find good machine learning models that are pre-trained already that belong to our field of interest. For instance, this Cell paper published in 2020 broad spectrum antibiotic activity prediction against, mostly tested against E. coli. They have basically released the weights of this network, so we can just bundle this network in our tool set, and then researchers can just query their molecules and get the prediction. Other times we are not so lucky, we don't have the model trained, but we have data, like in this case of this science paper focused on antimalarial drug discovery. So what we do is we gather the data from the paper, we train a relatively simple machine learning model, we bundle it, we deploy it so that researchers can input their query and then get the predictions. And most of the times, actually, this is where we spend most of our effort. We actually travel there, we identify their needs, we collect their data together, and then we build machine learning models in cooperation with them. Okay, so all of this research is actually being gathered into something that we call the Ercilia Model Hub. The Ercilia Model Hub is an ever-growing resource that grows more or less organically, and it contains machine learning models for drug discovery with an emphasis and with a focus on infectious disease research. At the moment, I believe we have about 70 models in the hub. Our hope is to reach the 500 models by the end of the year. You can visit it in our website. Why do we want to build such a hub? Well, because we believe that by having this such a hub, this toolbox of pre-trained, ready-to-use machine learning models, researchers can ask questions fairly easily without having to spend a lot of resources on actually testing or getting an initial idea about the interest of their compounds. Intuitively speaking, a compound will be a good candidate. For instance, if we are doing antimalarial drug discovery, if we can predict that it has an antimalarial activity, if we can predict that it's easy to synthesize, if we can estimate that it's going to be cheap to synthesize, and if we can predict that it's going to be soluble in water, for instance. And we also want this compound not to be toxic and not to block, for instance, hERG, which is, as we know, is a huge problem in cardiotoxicity. A bad compound would be a compound that doesn't do all the good things, but does all the bad things, okay? So these kind of questions are things that our collaborators can do very easily with our toolbox. For example, I would say our main collaborator at the moment is this center called H3D at the University of Cape Town. In South Africa, these people have been collecting a lot of assays for antimicrobial drug discovery, mostly malaria and mostly tuberculosis. They have about 13,000 molecules. They have been collecting data for over almost 20 years now, but they haven't done any predictive modeling on it. So we traveled there for about 4 or 5 months, and we built together machine learning models that now they can use as a complementary virtual screening cascade that can help hopefully enrich their experimental pipeline. And it does in prospective validation over the last year. We could prove that, that the hit rate that they achieve now is about 4 to 5 times greater than what they had before, which is quite great. So how does it work? How do we build these relatively easy machine learning models at scale? Because remember, we are a very small initiative and we need to ensure sustainability. So whatever we do needs to be simple. Most of the times, actually, the task that we have is what it used to be called in chemoinformatics, QSAR. And the idea is very simple. We have a set of activities. You can see them here on the right. Active means is in red, inactive is in blue. And we have a set of molecules. You can see them on the left. And basically, the idea is to map structural features of the molecule or physicochemical properties of the molecule to the activity. Yeah? And if we think about it, we can think about 2 steps, more or less entangled. And in the first step, we actually try to represent the molecules in a format that the computer can understand, typically a vector. And in a second step, we just want to fit a model that will be able to map this vector to the activity, yeah? To classify these vectors. So that when we come with a new molecule, for which we don't know the activity, just by looking at the vector, we will be able to predict whether these molecules will be active or not. So this is what we do more or less systematically. And basically, the kind of technology that we use is something that, together with Patrick, who I believe is here in the audience, we developed at IRB Barcelona a few years ago and was published in Nature Biotechnology. This is the chemical checker. The idea behind the chemical checker is to gather, to admit and accept and actually leverage the fact that there is a lot of information about the small molecules out there, and that it would be great to capture all of this information, to embed all of this information into a format that is computer readable. This is what we do for any molecule that you can think of in principle. We just take the chemical structure, we do the necessary inferences, we query the public domain, and at the end of the day, long story short, we come up with a long signature that hopefully captures all the information that we can gather about this molecule. So not only the chemical structure, but also some biological features, such as the biological activity, the side effects, or even the intended therapeutic outcomes of this molecule. So the chemical checker is a huge resource, and I believe the great advantage of the chemical checker when it comes to machine learning is that, as I said, it captures beyond the classical solution, which was only embedding the chemical information. It captures much more, in particular, the targets of the molecules, the network effects of the molecules, cell-based assays of the molecules, and also clinical data when we have it. The way we kind of organize and streamline all of this today is through this concept of the biomedical knowledge graphs, which basically is a way of organizing data that we find in the public domain, greatly pushed by our colleague Adrià, and recently published in Nature Communications. The idea is that we have this framework, this scheme of a database, where we can kind of map all the data that we collect in the public domain. This is now a resource called the biotech, and actually the biotech, I believe it contains about 100 million edges today. Here I'm just showing an example of 50,000 edges that we produced at the beginning of compilation of the biotech a few years ago. All right, so back to the chemical checker. The chemical checker, as I said, is a database of biological signatures that we can use for machine learning. Contains 5 levels of, if you want, increasing complexity. And we believe, and we have actually proven, that it can be very useful as a starting point for building activity predictive models for small molecules. Some of the molecules, for some of the molecules, the data that we have is actually experimental. For many of the molecules, the data that we have is actually inferred. And this is something that we published together with Martino, who's also here in the audience, in Nature Communications last year. So the question is, so is it useful? Well, I believe it is. Here I'm showing different TSNE representations of the molecules. You can see in the first line molecules stratified by different therapeutic indications. And you can see, and they are mapped according to this chemical checker signature. You can see very easily that depending on the therapeutic indication, molecules will fall in a certain region of the chemical checker space, which indeed proves that those signatures are informative. The same applies beyond drug molecules. If we focus on species metabolites and different species, we also see some kind of organization. Same happens if we focus on tissues and fluids of human, and same happens if we focus, for instance, in food ingredients. So hopefully we can claim that the chemical checker is broadly applicable to a broad collection of chemical matter. When we apply it into machine learning tasks in particular, we can run several benchmarks. Here I'm just showing a typical benchmark called the molecule net. The nice thing about the molecule net is that it goes from biophysics benchmarks to more physiological benchmarks in orange. And you can see here in blue that the chemical checker especially outperforms in the more physiological tasks, which are typically more difficult to predict if you only have structural data. We are building upon these kind of machine learning tools now at Ercilia and trying to bring in additional types of information for the molecules, and this is something we are compiling in an AutoML tool called ZyraChem that we are about to publish. Focusing back on the molecule net, I'm focusing here on a kind of benchmark which is very popular called TOX21, where you basically try to predict 12 toxicity outcomes, I believe, of small molecules. In blue here you can see the performance of the chemical checker-based prediction, and here and in red you can see the performance of the chemistry-only based prediction. And as you can see, most of the times, if not always, the chemical checker beats the state-of-the-art based on only structural data. Not only this, but by using these signatures and by mapping them accordingly on the 2D space, we can gain some kind of interpretability, and more importantly, I believe, The models that we built are more robust. This is what you see in the small inset there. Basically, as we remove more and more data from the training set, you can see that the performance of the chemistry-only based models drops dramatically, while the performance of the chemical checker-based models stays the same, which effectively means that, in principle, we are able to build good models with less data. All right. Yeah. A pattern that we've always also seen here in these talks is that a goal of machine learning is not only to predict activities, but actually to the reverse. Try to predict, given an activity of interest, try to predict molecules. This is something that we've done a lot, especially in the context of antimicrobial drug discovery. Here you can see a project that we did as part of the Open Source Malaria Consortium. Starting from a molecule like this, we've produced thousands and thousands and thousands of candidates that we can then explore in a map like that, so that researchers, our collaborators, can identify nice candidates, synthesize them, and test them in the lab. Yeah? Exactly the same type of approach we've applied with, more generally speaking, with antibiotics in collaboration with the lab of Patrick Alloy. And here you can see also some instances of the molecules that we have predicted with some docking, quote-unquote, validation. So you can visit our website and see and actually see that all the research that we do. We do several projects across sub-Saharan Africa, and we are building several tools. So feel free to visit the website and reach out to me. I think this is all. Just to summarize, we're a small nonprofit. We aim to democratize machine learning and artificial intelligence applied to drug discovery, in particular in the Global South. And yeah, everything we do is open source, and I'm happy to take questions. Thank you.
Thank you very much. I really like the talk. So we have time for one question.
Maybe, okay, thank you. So thank you for the super interesting topic. The question is, do you actually work with pharmaceutical companies here? Because I think there is a lot of room for like addressing unmet needs. So is this something going on, or do you expect to grab attention from this sector?
Yeah, thanks for the question. We have done one project in particular with Merck, the pharmaceutical company, which is related to trying to find interesting ways of unlocking their data. So as you know, pharmaceutical companies, they would compromise their IP if the identity of the molecules that they have would be revealed. So the approach that we proposed to them was to actually release not the data themselves, but actually machine learning models that have learned the patterns on that data, right? So we build machine learning models based on their data, hopefully. Then we just publish the machine learning models encrypted, so the molecules cannot be reverse engineered in principle. And effectively, the public domain has access to that data, even if we don't know exactly what molecules they used. This is something that we have already kind of finished.
Thank you.
I have a very simple question or naive question. How individual researchers can contribute to this initiative?
Yeah, thank you. So basically, we are a very small team. We work basically remotely within our team most of the time, because we travel essentially nine months out of 12 in the year. But we nonetheless have a small community. And our small community, I checked this morning, we are 54 contributors at the moment. Everything is basically functions like any open source community. We have our GitHub repositories. People can raise issues. People can do pull requests. We accept, and then all of that. So we do have a Slack channel where many of our contributors and volunteers actually participate, and it's quite active. So everyone is free to, of course, to join this Slack channel. If you are a researcher working on AI, and in particular AI for drug discovery, I think that the best thing to do would be to just write an email to us and see whether we can deploy our model in our system. That would be great.
Okay. Thank you very much. So thank you, and let's move to the next question. So last but not least, Alba Jané from the Barcelona Supercomputing Center, a dear friend of mine, who is going to talk about the Bioinfo for Women program. She's part of the steering committee. And the talk goes in the direction of towards gender equity and diversity in science. Alba?
Thank you, Salva. Hello, everyone. I will try to be brief but clear. I'm here representing the steering committee of the Bioinfo for Women program. This is a program that started in the Life Sciences department of the Barcelona Supercomputing Center almost 5 years ago. And it was initially started by Alfonso Valencia, there on the back of the room. And thank you very much, Alfonso, for that. So with the vision that the science done by women should be more visible, because it was usually less visible and women had less opportunities in science, but more specifically, we were focusing on the field of computational biology. And here I will give you an overview of what we do, but more specifically I will focus on one of the activities that we have been pursuing in the last year, which is a pilot mentoring program that we have started at the BSc. So this program comes from this context in which there's an unbalanced representation of researchers, especially when you go towards the more computational and technical fields. In bioinformatics, we are in a way marrying two disciplines, biology and computation, but we still have an important gender bias in the center. So as you can see here, this is the statistics for the world, for Spain, and for the BSc. And this is in terms of women and men, the total amount of researchers in general. So you will see that in the world, we are not faring that well. We're faring a little bit better in Spain and at the BSc, but we still have a lot of work to do. And this is also true at the level of PhD students. And if we go upper and upper in the ladder of leadership, this even becomes more apparent. So we had several brainstorming sessions and we started humble. So we thought, how can we improve the situation? So we have basically taken activities on the axis of women leadership, visualizing the work done by women, promoting collaboration, role models, and all these in the field of research in computational biology. And I will tell you now how we did it. So as I said, we started very humble, and we were basically organizing some seminars in which we featured the research done by international women, and this was before COVID. Then we were also hosting 3 women researchers who had been postdoctoral researchers in the lab, and then they went on to establish themselves as independent researchers. So we supported them financially, but also through other means. And this was an initiative from the lab. So it was a small first step, but very significant. But then during the pandemic, we were reformulating a little bit the program and saying, okay, we can go much further than that, right? So there's, I don't want to read everything. I have a poster, so you can come to the poster session afterwards. It's almost right in front of these doors. So we can talk and maybe discuss this more in detail. But basically, we ended up establishing these 5 axes in which we thought we could do something. And today, I will be focusing especially on the support of the women's scientific career, and more specifically into the mentoring program and how we can promote international role models to junior researchers, and with the aim also to build an international network of mentors and mentees. So this is a question we get very often: what can Bioinfo for Women do for me, for my institution, for my community? And my question is reversed, also what can you do for Bioinfo for Women or for any other initiative that could be in your institution or that you may even start? So there's several layers at which you can at which we can interact. One of them is to find role models. You can be a role model yourself, being a man or a woman. Of course, we welcome both role models as long as we share, the same values. As a student, you can be promoted for exposure of your research, and you can receive training. As a postdoctoral researcher, you can be locally invited at the BSc. At least we invite women researchers specifically within the program, and you can deliver or receive mentoring depending on the stage of your career. As a PI, you can, of course, also deliver seminars, you can become a mentor, you can contribute to the research line, and you can be a role model. And everyone can contribute to scientific publications, collaborations, and increasing this networking amongst different institutions and initiatives to promote gender equality culture. So, yeah, there's things that we do at the BSc level, and there's also things that we do at the more international level. At the BSc level, we do small things that have resulted in very interesting results, like, for instance, something as small as just showing the research that you are doing and what we call the BioInfo Women's Day. This is on 11th February every year. And why this date? Well, this is the International Day for Women and Girls in Science. And we chose this day and we did something very, very small and simple, which is just invite master students and in the area of Barcelona or Catalonia, just for proximity, and we invite them to visit our center. And they sit next to women researchers or technicians or PIs in kind of different stations. They sit next to them in very small groups. And they just have informal conversations on what is the day-to-day of this postdoctoral researcher, master student, or principal investigator or technician. And in this way, they can see themselves, men and women, boys and girls, at the master's level, at the degree level, and at the undergrad level, and PhD level, sometimes even from other institutions. They can see themselves, they can project themselves on that role. And this role model that we're providing, it happens to be a woman, right? Through this initiative, for instance, we have recruited very, very nice talent, great talent in the institution. And it's something small that had a very nice result. This is the BioInfo for Women's program. BioInfo for Women Fellows, program that I mentioned before. So we have one person from Toulouse and another researcher from Marseille. Actually, Anaïs Bodot, I don't know if she's in the room, but she's one of the BioInfo for Women Fellows that we have in the program. So we are supporting these two women that have become principal researchers, and there has been very positive feedback so far because they are not alone in this transition to becoming a senior PI, but they come with a big institution behind themselves that is supporting them in the start of this career and maintaining these collaborations. We also provide PhD training, and by incorporating a gender perspective in research. Davide already and Maria Jose talked about the book that you can maybe check if you want. It's in the BSc booth. This is a book on sex and gender biases in health and artificial intelligence in collaboration with the Women's Brain Project. And we have been promoting non-purely scientific meetings, such as with women leaders that act also as role models at the BSc, but also in other conferences and events. So this is the seminar series, just an example of the seminars that we have been doing so far, which have received great attention, and all of them are in a YouTube open playlist, so you can search for that, and they are all recorded. You can browse them and watch them again. This is just an example of some conferences and events that we organized, and this is actually, this photography was taken just before the pandemic. We organized a conference with only women speakers here in Barcelona. It was extremely successful. This is just an example of some institutions with whom we have been networking throughout these years. Also to highlight that the BioInfo for Women program is an ECCB affiliated group officially from now onwards. We have a Slack channel that you can join if you would like. We can send you the link afterwards to be in touch. And I will focus now on the mentoring program, which is a pilot that we have just started now. So very briefly, the BioInfo for Women International Pilot Mentoring Program for young scientists is the official name of the program. And this all started because we wanted, in this case, PhD students to have a role model who was a woman or a man that shared the values of the BioInfo for Women program. And we opened it to both men and women. For now, at the BSc, and 2 people from outside, 2 women from outside who were PhD students or very junior postdoctoral researchers. So this pilot started with 8 mentees and 8 mentors. And this is the long-term objective that we have, is to encourage the proactivity in career management and increase this high-quality feedback that they can receive from someone from outside their institution. So this mentoring program is pairing people from outside the BSc with students from the BSc. Okay? And this brings in some additional expertise outside their outside the usual bubble, which is very positive so far. And in the short term, we have initiated this pilot, and we are thinking to grow this pilot and to become a program that maybe can expand to promoting leadership into more senior positions. Especially, we want to focus on the transition from postdoctoral researchers to PIs, because this is a step that typically is more difficult for women, because you typically take more responsibilities, and this means, less time for the family, and as we all know, sadly, this has a detrimental effect into the career of women. And these are the very brief numbers and some of the benefits that we thought could be derived from this program. So for mentees, we are providing them access to a wider professional network, because these people is from outside the BSc, they're mentors. They are also exploring goals and achievements with more experienced scientists, and usually these scientists, the mentors, are from outside their field of expertise, so they provide a fresh point of view, and this all results in enhanced career opportunities and in better self-awareness, right? And then in the case of mentors, they develop strong relationships with their mentees, and for some of them it's the first time that they have a mentee. They also will have an increased role profile for those that didn't mentor yet anyone, or it's always a very nice experience. And this also means that these people are in touch with the BSc, which is sometimes an interesting institution for them to be in touch with, and maybe the start of new collaborations in one sense or the other, right? Also in the scientific area. So this is just a little bit the timing. We would be here. Who would be on this side. We have provided professional training for both mentors and mentees, and some people felt this was weird at the beginning when we were saying that we were providing training to mentors. Some of them are very highly experienced women leaders, but actually they all provided very great feedback. So this is a satisfaction questionnaire that we sent. These are the answers, because actually, one senior woman leader, she mentioned that you always learn something new from these professional trainings, right? Because they are training you on transversal skills. And for mentees, we provided them also some training on how they need to conduct these mentoring sessions, which are started by mentees. So we rely on them to call on their mentors and to propose what they want to discuss, okay? So we foresee that this will wrap up and finish on June 2023. We will evaluate the program, and we will, before that, start thinking on what are the next steps. If any of you would be interested to become a mentor of the program, you would be very welcome. Just please contact me, because this has been a very positive experience so far in this midterm evaluation that we are conducting now for the mentors who are participating. And it usually boils down to conducting one session every 4 to 6 weeks. So it's not that much. Sessions last for about 1 hour, and the mentees highly appreciate that. It can have a really important impact in their future. And this is just a couple of quotes that we got from mentors, also with some nice ideas, right? Some are suggesting to improve leadership skills on themselves, so to receive some training as mentors on leadership skills, and others are proposing to establish a network of mentors, which is obviously something that would be very keen to do, and we think that it can be for the benefit of all. Here we can benefit more junior scientists and more experienced scientists equally. So having said this, I thank you for your attention. I will be at the poster session, so you can come talk to me or to any of the fellows at the Bioinforming program. So thanks.
Thank you very much, Alba. We have time for 1-2 questions.
Yeah, hi. Thank you very much for the interesting talk and for the great job you're doing. You showed that you approach students and PhD and the further steps. Do you think that it might be or it might make sense to approach girls in schools or even in kindergartens and to show them that, computer science is interesting. It is also for girls, or even go to the kindergarten and show, girls can also play with Lego and not just people like dolls and stuff like that. Do you have something in the program?
So definitely, thank you for the question. So I showed you here the Biome for Women program, which is focused on computational biology. But as a center at the BSc, we also have a program running for girls. So for boys and girls, but with a focus on girls in schools. Actually, I think they are like 7 and 8 year olds, and they are planning visits to the BSc with a person that is showing them what is supercomputing, and they are actually playing with Lego bricks and things like that, learning what is parallelization of jobs and things like that. And they visit the Mare Nostrum, which is a nice supercomputer to visit. And the program has been running for a couple of years, at least 4 years, as far as I'm aware. 4, yeah. So this is an institutional program, not focused on computational biology, but it's something that we do as a center. Definitely, it is important to sensitize girls from very early ages. Yes, definitely.
Thank you very much.
Well, I'm not a woman, but I like to support your initiative. And I do want to make some comments and then maybe ask you a question. So I saw there's a wide diversity within biomedical informatics. I saw some statistics in health informatics. They've been doing really well, where 60% of people are women. And then in data science, according to statistics, only 10% were women. So probably the comment here is you can learn what health informatics field have been doing in this new emerging field. And the second, actually my question is more about this, your mentor selection and the mentees. It seemed to me that you're focusing on women for women. I wonder if there's a role for men, because we also love to support women as well. Thank you.
Thank you very much. It's men like you that we need as allies for the program. So just to clarify, we work to promote women in science, but it's open to men and women. We love to have men who think alike, because in the end, diversity is what makes science and any job successful, right? Any field. Regarding your first question, you mentioned in different fields there's different percentages of women, and some are doing better than others. That's true. We are in a supercomputing center, so life sciences department is just part of it. In the computer sciences department, well, things are not faring that good. And actually, when you look at more technical profiles in the computational biology field, there's a high bias still towards men. But also when you scale up in terms of leadership, even in the medical field or other fields where there's more women, in general, the majority of the leaders are men still nowadays. So it's not only a matter of looking at the big picture, but also in terms of layers, no? At the leadership layer, we need to definitely improve this. Just think who is the director or directors of your institution, whatever that is. Okay, I don't want to make a poll now, but I'm sure. Yeah, it would be quite clear, I'm afraid. And your second question was, which was it? Sorry. Oh, participation of men in the initiative. Yes, of course. So the mentors can be either men or women in our program. We welcome very much men. Where the rule we established at the beginning is not to have a man mentoring a man. That's the only rule we decided at the beginning. This can change in the future, but at least this is what we thought was correct to break the bias, at least a little bit. Definitely. we need you.
Thank you very much, Alba. Thank you very much to all the speakers. A nice time for coffee and to continue the discussion, because the session has been quite productive.